Good morning, children. In continuation with chapter 3, extraction of metals. In last topic, we have discussed about that there may be minerals and there may be ores and how they occur in the nature. We discussed that minerals are the elements or compounds which occur naturally in the earth crust and are called minerals. But ores are the minerals which contain very high percentage of a particular metal, and they can be extracted profitably and economically from these minerals, and they are called ores. We have also discussed that all ores can be minerals, but all minerals cannot be ores. The occurrence of these metals, we have discussed that very reactive metals, they are not found in the free state. They are very strongly bonded with chlorine and oxygen. Generally they are found in the compound form, so their extraction can be done by electrolysis. Zinc, iron, lead, mercury, these are the middle and low reactive metals. They occur in the form of sulfide, oxide or carbonate ores, and in the flow chart we understood that how these metals are extracted as per their reactivity series. Now we will discuss some of the examples of this. That we have discussed about this gangue also. Gangue is the usually contaminated with large amount of impurities, because ores contains the large amount of impurities like soil, sand, etc., and that needs to be removed, which is known as enrichment of ores. So let us discuss some examples of roasting and calcination today. Roasting is the heating in excess of air to the sulfide ores. For example, copper sulfide, which is known as copper pyrite, cinnabar, which is known as mercuric sulfide HGS, or zinc sulfide. Here we will discuss one example, that is zinc sulfide. When it is heated in presence of excess of air, it gives zinc oxide and sulfur dioxide gas is evaporated away. Because zinc is a middle reactive metal, simply by heating it will not leave oxygen atom, rather we have to go for the reduction of it. Before we start for the reduction, let us discuss what is calcination. Calcination is of carbonate ore, and what we do, we heat the carbonate ore in limited air. So zinc carbonate is heated in limited air such that carbon dioxide is given out and leftover metal is zinc oxide. Now as we have obtained zinc oxide after the oxidation of zinc sulfide, similarly after the calcination process we have also got zinc oxide. So the common process for both of them, that is the removal of oxygen so as to obtain the pure zinc metal, is reduction. All of you know, have learned in chapter 1 also, removal of oxygen from an oxide of a metal or a non-metal is known as reduction. So what we are doing here, metal oxides are reduced to corresponding metal by using some reducing agent, and here we are using reducing agent is carbon. So when zinc oxide is heated in presence of carbon, it converts into the zinc and carbon monoxide is evolved. Why? Because carbon is a small size atom and it has great affinity for the oxygen, much more than zinc. So it pulls out and takes away the oxygen, thus leave out the zinc pure metal. But children, whatever processes or whatever metals we have obtained by the process of roasting or calcination, they are not pure. For your information, जो आगे हम पढ़ेंगे, that even 0.02% of impurity of any metal or a non-metal will change the properties absolutely different. So if Some of the impurities are left after the reduction, calcination and roasting that needs to be removed for sure, and that process is done by electrolytic refining. What we do in electrolytic refining? We take the pure metal and an impure metal. We do a smart process here. We take anode as the impure metal and cathode as the pure metal. For example, here we are doing electrolytic refining for copper. So as you can see in the diagram, we are taking anode as the impure copper and cathode as the thin strip of pure copper. And the electrolyte solution used in the tank is acidified copper sulfate solution. So that when we conduct the electricity with the help of a switch and battery or the AC electricity, as this is have a very big plant, so when the electricity flows through this circuit, aqueous solution of copper sulfate will enhance the conduction of electricity and the copper ions will move towards the cathode. As you know, positively charged particles will move towards the negative electrode, that is cathode. So copper ions move towards the cathode. Slowly and gradually, with the conduction of electricity in the solution and through these rods, that is anode and cathode, anode we have made of impure copper. So same charges will repel each other. So copper leaves the anode and it starts moving in the solution, and slowly and gradually it moves towards the cathode. So this way, continuously there is a flow of copper ions from the anode to the electrolyte solution and then towards the cathode. So after some time we get pure copper at cathode. Children, you need to remember this thing, that this process is not only for copper but it can be used for zinc, iron, nickel, aluminium, this type of the metals, and tin, which are given in your NCERT. So I hope you are very clear about this process. So please revise it thoroughly, but from the NCERT, by the combination of NCERT and the notes. Notes I will upload on your class. Thank you, and ERP as well. So thank you.